Um, Hello, everyone. Uh, Welcome to my talk, Experimental Refactoring. It's good to see so many faces. I hope you're excited about today. There's some great talks later on as well. So yeah, Experimental Refactoring. Ooh, cool. First of all, I'm Jelmer Snoeck. I'm a technical lead for the operations team at a company called Manifold. And I mainly do Kubernetes and Terraform integrations there. So it's all in Go. And yeah, we build a lot of integrations on top of those tools. I've been doing Go for quite a while now. And I'm also a Kubeless contributor, in case people know that. And I have both stickers of those if you're interested. So this talk, obviously experimental refactoring, is quite lengthy. We're going to go over a lot of things, but there's actually like a few main topics in there. So first of all, we'll look at what refactoring actually is and why we do it. We'll also have a look at some techniques and some tools, and these are mainly tailored to Go itself. Like I've chosen a few that I find very interesting in the Go community and like the Go toolchain. Then we'll also dive into the actual refactoring with zero downtime refactoring and experimental refactoring. So refactoring. So this whole talk is about it. So what we want to do first, obviously, is like kind of define what refactoring actually is or what it means to us. So Wikipedia defines it as code refactoring is a process of restructuring existing computer code without changing its external behavior. That's quite straightforward. So we want to restructure something, but we don't want to change anything else, right? Martin Fowler defines it as refactoring is a control technique for improving the design of an existing code base. So we want to improve the design of our code base. We want to make improvements to that. And again, you kind of want to don't change anything in your code base, in your behavior, basically. Refactoring is also changing things, deploying it, and hoping it didn't break anything else. And that's what most developers think about refactoring. And that's what this talk is aiming. Like, we're going to try and like get you out in a space where you don't feel this anymore. And that's what this is all about. So we defined what refactoring is now, but why do we do it? Why do we want to restructure our code? Why do we want to improve that design, right? First of all, we do it for readability. There's this common saying that you read code a lot more often than you actually write it. And it's kind of true. Like, it's not kind of, it is actually true. So to actually understand what you're reading, so you might have like large methods. To actually understand what you're doing there, you actually start refactoring in your head a little bit already. Like, you just look at a tiny little piece of code and you just like take that out and you just analyze that bit. So that's what we're going to do for, that's what we're going to refactor already for readability. Another big reason is code smells. So code smells are characteristics that there's a deeper problem in your code base that you want to tackle. You see issues and you want to fix those. Some code smells, examples of it is duplication, feature envy, large methods, dead code, and so on and so on. There's like a whole list of them. Another one is bugs. Everyone knows it. If there's anyone who hasn't found a bug yet, let me know. I'd like to talk to you. But everyone knows it. And sometimes, like most of the times you're going to fix those bugs, you're going to have to change your code base. But it could also be that this bug is not really worth fixing, and then your product team decides, we're not going to change this. And that leads us to another topic, is product changes. So your product department might be like, oh, we need a new feature. So you're going to have to adjust your code base for that. Or your product department is going to say, we need to modify this feature. Like, we did some user testing, it's not working as we expected, users are interacting with it differently. You're going to have to change your code base for that again as well. And the last one that is often like the hard and interesting bits are performance and scalability reasons. So performance-wise, we make these applications, we have our code base, and we write these things to be as performant as possible. And we also want this to like reach as big as an audience as it can. So for performance reasons, we might want to change the underlying package to something that's more suiting for what we have. But we might also want to change the underlying algorithm that we wrote to do something. We'll see a few examples of this later on as well. For scalability reasons, as just starting out, you have 100 users, and your user base grows, obviously. If you reach the point of 100 million users, your database scheme is going to look a lot different than when it was in the beginning. You're going to have regional caches. You're going to have to think in your code base how you're going to handle these things. But another part of that is also team growth. So again, when you start out, you might have a few developers, but when your team grows to like 500 developers, accessing that code base is going to look a lot different than when it was when you were just a small team. With the rise of microservices, that was like a whole impact on that as well. It's a great tool to help with that, because every team can just own its own microservices. That's a great step forward. But again, you're going to have to think how you're going to enable developers to easily do changes in your code base. So that was part one. I'm a huge fan of dogs, so you see a lot of dogs in these slides as well. So yeah, that was phase one, or part one. On to the next bit. So some techniques. Again, these techniques that I've chosen are quite tailored to Go. Obviously, this is Go conference. And yeah, they're here to achieve the optimal results, basically. And it's quite interesting what Go has to do that. So these are the ones I'll go over. There's obviously a lot more, but there's not enough time in the whole conference to cover all of them. So interfaces, or interface abstraction. There's been written a lot about interfaces, and you can actually write a lot more about it as well. So we're going to go over it very briefly. And I think my computer just froze. Oh, there we go. All right, cool. Computer's right. So a small example here. What we have is a Redis client, and we also have a store item function. So all these examples you'll see, by the way, in this talk are super simple. They might not make a lot of usage sense, application-wise. It's stupid examples. It's just to try and highlight the points. So we have a store item function. It does some mutation to the data, or adds some extra information. Then it's going to store that data. And what you can see here is actually it's taking that Redis client, and then it's doing some specific action on that Redis client that it needs to know of. That can return an error if that errors or application is oh no, we need to error, panic now. This is, for us, it's critical. That needs to happen. We need to be warned about that, or alerted. But we found that Redis is not really the right solution for us. So what we're going to do is we're going to swap that out with Memcache. And again, we create new clients. And then instead of using the Redis client in that store item function, we're just now going to use the Memcache clients. And as you can see, that method, actually, the set method actually changed quite a bit because the interface for the Memcache client actually changed quite a bit as well. It's taking different arguments, right? So we have to change our code for that, which is not that great. Especially if we want to think about further, is we want to experiment with this as well. We want to validate that this is actually the right approach. So to do that, what we do first is we create an interface. So we create the store interface, super simple, just takes a key and a value, and it's going to return an error. What we then do is we add 2 wrapper clients around these interfaces, or that implement these interfaces. Each have their own underlying clients, and they know how to actually speak to that storage solution. And what we then do is we actually say we're going to update that store item function, and instead of taking that specific implementation of the storage client, we're just going to use that interface. We don't care anymore what's in there. We're just going to use that interface. And then we're going to say we're going to create a Redis client and a Memcache client. And then we're going to store the Redis item, or the item in Redis. And if that errors, we're still going to panic. That's still very important to us. But the interesting part here is that we're going to actually say we're going to try and store this in Memcache as well, but if that errors, do not panic. We're just going to log that out, and then we can analyze that later on. Then we can evaluate that this Memcache solution is actually what we want. And that's the first step that we can do to actually achieve experimental refactoring with interfaces. So the next part topic is type aliasing. Type aliasing got added in Go 1.9. It actually is added to do refactoring. There's a great blog post about this on the Go blog. It's linked at the end of these slides as well. And you'll see a lot of the topics in that blog post actually be in here as well. So yeah, type aliasing. What actually is it? So we'll look at an example again. Again, it's super simple. But we have a framework package here which has two models. It has a user, and then it has a project with some users, which is apparently a pointer, not a slice, but anyway. But that just references itself, the same package, right? But we also have this package called server, and that just has an endpoint where we're going to list a bunch of users. Again, like the rest of the implementation isn't really important here, but we're going to get data from the database, we're going to load that in our slice of users, and that's it. Now that we found that our user actually, like, it should be in its own package, it's being reused so often, and it's like has a lot of extra functionality, so it can actually live in its own package, right? So what we do is we move that to a users package. So we have a new package, users, and we have the struct user in there. But if you think about that, so we referenced in the framework, we referenced user already. In the server package, we also referenced the framework.user. Like if you move that object from one package to another, your code isn't going to compile anymore. And in this example, it's super easy now, right? It's 2 lines of code that we have to change because it's so simple. But imagine projects like Kubernetes or Docker, like that have external users as well. If you actually move from one package to another, that's breaking a lot of code for a lot of people. How can you actually solve that without doing that? That's using type aliasing. So what we're going to do here is we're going to just add a type user, and we're just going to say this actually equals the type user from the users package. And then you don't have to change your project. You can still keep using that. And you don't have to change your server package either. So what you do is you just extract that package, you just ship that, and that's it. And eventually, like, gradually start replacing all the code bits that have that as well. You just say, like, I'm going to, instead of using the framework.user now, I'm going to start using users.user. And you just do that over time, and once you're confident that everything is done, you just remove that type alias. So the next one is nil objects. I think that's a very interesting topic in Go, and Francesca actually wrote a very or actually did a super awesome talk about that. It's also linked at the end of the slides. Definitely go check that out. But it's a little bit undervalued, I think, as well in the Go world. So a quick example again with nil objects. So we have a user here, and it has some roles. And then we also want to check if this user is actually an admin. So imagine that we have a website, and you can also have visitors, right? So a visitor is not an admin. A user that doesn't have admin rights is not an admin either. So what we do to actually check if this user is an admin, if we just go over the roles, and we say, if the role is admin, you just return true. Pretty simple. And then we have our little application. We say, the user, get the user, John, and then we're going to check if John is an admin or not. And again, like I said, this is like a service where you can have guests as well. This user might actually not exist, but it might. And in this case, it doesn't, and it returns a nil object. So what's going to happen is we're going to have a dereference error. This is failing, obviously. So the way we think, we're going to solve this is just add this, right? If user equals nil, then you say, it's not an admin, and then return. The issue here is that we actually make the end user, the developers, like the people who are going to use this user object, they need to now check that this is actually nil or not. So we move that problem like way up to the consumer, basically. So what we want to do is we actually want to say, so you don't have a dereference error anymore, so it's not panicking. Great. But what we want to do is we actually want to say, in our user object, we actually want to say, if my user is nil, it's not an admin either. It's just, obviously, if there is no user, it isn't an admin, right? So we move that responsibility of that check actually to the user object itself. And that returns false as well. And that's basically nil objects. Very powerful, but you have to think about that a little bit. Cool. So we saw some tools. And now we saw some techniques, and now we can look at some tools. I categorized two tools, basically. The first one is detection tools. So detection tools are basically tools that help you notify you when basically there is something, a code smell or something like that, when you can say like, oh, we should probably look at this code base and actually do some improvements, do some restructuring. The first topic I wanted to look at is CodeGov. So CodeGov itself is actually a service, but it's actually using something from the code toolchain to do its stuff. I'm just going to have a sip. So what CodeGov is actually going to do is actually going to use coverage reports that are generated by Go, and it's actually going to make a UI now. We'll look at that in a bit. But so I mentioned this coverage profile, right? So what you can do is actually you can say, I'm going to run my tests, and I'm going to get a cover profile out of that. And so as you can see here, it actually runs your tests. So like there's a failure here as well, so you actually will see your failures as well. But the interesting part is that you will also see how many percentage of your, or how much of your code is tested. So at the end of each line, you see like coverage, and yeah. So for each package, you can actually see that, which is pretty cool. And then the more interesting part is you can actually get some output of that as well. You can get a more detailed output of that as well, and that's this. So you can like get an HTML version out of it. You can like get text out as well. But I found the HTML one is a lot easier to work with. This is like a great way to start doing these things locally. Like when you're developing, like it's like very easy to like spin this up. When you run your test, you just get a coverage profile out, and then you can like look at the coverage. So what you can see here now is that we didn't test that for loop, for example, or we didn't test our error case, but we thought we did, but that actually means that something is wrong in our test, and we can actually start analyzing that and like go in deeper, right? And sometimes, like if you don't have these things, or don't have these tools to help you with that, you don't know. So what CodeGov then is actually going to do is going to go a step further. So what we saw earlier in this slide, so what we saw here is that it's like a local image of what you currently have. But what CodeGov is going to do is actually going to say, oh, I'm going to compare that. If you do a pull request, I'm going to compare that to your base branch, and then I'm going to show you actually like decreased or increased code coverage. So we got like the left side is your master branch, the right side is the branch that you're doing a pull request from. And you can see like for some lines we added coverage. For other lines, the coverage dropped. And that's a very like interesting bit when you're refactoring. For example, if you did a code change where you remove some code, and you're like, oh, I'm going to remove some tests as well, but you removed a little bit too much of your tests, you can now know. CodeGov also does like an overview of your packages. It's like visually, it's like easier to just dive in straight away then. And then you can also do this. So it will do a report on GitHub, and it will actually show you like you need to like work on this. You decreased coverage. So the next section, or the next detection tool is linting, and this is like again like heavily built into the code toolchain as well. I'm going to look at very basic examples. There's a lot more to cover here, so definitely like look into that on your own as well. But the first example we'll look at is with GoVet. So what we'll do here is we're just going to print a statement, and we want to do some interpolation on that. So this is actually valid Go code, obviously, but your output might be different than what you expect, because we didn't do that interpolation, we didn't give it an argument. So this will compile, but you might not get the result you want. And this is what GoVet is there for. It will actually show you like, oh, you might not want this behavior. And it's going to alert that you didn't have an argument. So at the end of the statement, you should probably give it an argument. Again, this is a very simple example, but it gets way more interesting if you look at something like this. So this is shadowing. So shadowing is basically if you have a variable and then in another statement you like override that variable and assign it. You basically mask it. But you might not like, this is hard, like you don't really catch this when you're reading it. But what's going to happen here is that, so our first variable numbers is actually going to just be an empty string at the end, even though we assign numbers to it. That's because we reassign to numbers within that for loop. And that might be expected behavior, it might not be. You might want to assign that to the outer variable. And again, the compiler is not going to complain about these things because this is valid Go code, but your expected behavior might be different. So what you want to do is actually go and check that. And if this should be different, if this is expected behavior, you should probably rename that variable in the for loop. If it isn't, then you need to figure out how you can actually fix it. An extension on that is a tool called Go metalinter. It's a great tool, like it runs just a bunch of checks, like I think there's det code here, vet is running here as well, and it has like a bunch more linters that you can run on that. And you can build that into your CI, and then you have like consistent checks across everything you do. It's pretty cool. Okay, so we now have tools that alert us or like notify us when we should probably refactor. We should clean up our code base. We're going to look at some tools now that actually help us do that refactoring. I'm not going to go into tests too much. There are actually a few talks about this. I'm just going to go over a tool that helps you write tests. So tests are basically like some security that when you do refactor, it still works, right? Then benchmarks, I'll go into that in a little bit. And then IDE, I'm not going to go into that at all. But just know some of your IDEs that you use might help you like do some refactoring as well. If you use Vim, like I do, there's a lot of plugins that help you with that as well. So the first one is Go tests. So note that it's plural, it's Go tests with an S at the end, and there's no space in between, so this is not within the tool chain. It's actually a separate binary. But it's a great little tool, and it has like plugins for a lot of editors. But what it's doing is very simple. So again, we have a struct, GopherCon, and then we have location, and we want to build a title for that. What GoTest is actually going to do, I don't know if that's readable, hope it is, but what GoTest is going to do is you say, oh, give me tests for the exported function in this file now, and it's just going to output code, right? So it's actually code generation again, and the nice thing with this is that for everything you do, for every function or every struct that you have, the test is in the same format, so you don't have to reason about how you're actually going to like read this test. It's just always the same. So we put that in our editor, and then we immediately we see there's a to-do. You need to add test cases. Obviously, like you want to properly test this function. You don't want to leave it blank. But that's the nice thing. The only thing you have to do from now on is just add some test cases, and that's it. So we do that, and we run these tests. Probably a bit small for the back, but we run these tests, and we see that it immediately works. And again, like this is pretty easy to use. Like it helps you refactor quite easily, and it's very consistent as well. Like the format of these tests are always the same. You're probably going to have some cases in your code base where this doesn't work, where you have to like do extensive setup, where you have to do like some complex checking. But for a lot of cases, this will actually work, and it's pretty useful. Then on to my probably favorite part of the whole Go tool chain is code test bench. So I used to do a lot of performance optimization, and this tool actually helped me a lot with that. So GoTest Bench helps you optimize at the unit test level. So you're writing sort of unit tests, and you can actually like get benchmarks out of that. So we'll look at another example here is concatenate strings. So we're going to take a value, a string value, and then we're going to say we're going to make concatenate this L amount of time for length. We're just going to loop, and then we're going to just slam those two strings together. We're going to write a benchmark for that. And so the benchmark is pretty simple, right? So you just go over a number that's automatically generated for you from the tooling. So Dave Cheney actually wrote a blog post about this way more in detail that I'm going to go in. It's also linked at the end of the slides. Highly recommend reading into that as well if you want to write more benchmarks. But the cool thing is as well, like your code is now sort of tested as well, right? Like it goes through everything, and you validate that it still works. So to actually run your tests, you just have to add go test and enable the tests dash bench. And then an interesting part is I can also say I'm going to get memory profile out as well. So what we see here is that our test runs 2,000 times. It takes a lot of nanoseconds to actually do it. It's consuming a lot of bytes, and it's doing actually quite a lot of allocations. And the allocations is what makes this function run quite slow. So we start thinking, and we're like, oh, we heard of this thing called buffers. So let's implement this with a buffer as well, right? So we create a buffer, and then we just write to the buffer. And at the end of that, we're just going to output a string of that. So the same behavior, just going to take a value and a length as well, so how many times we're going to append it, and that's it. We write the benchmark for that as well, and immediately we see that this runs 50 times more often than a string version, or the concatenation version. And we also see that it's using a lot less memory than before. And the important part here, well, at least to me, is doing a lot less allocations. That's what is speeding it up. And that's like a very important thing to notice. And like, this is very useful if you're like refactoring, if you're changing your algorithm. You can actually test this and validate this at a unit test level. All right, that was phase 2. And I've seen like a few people actually doze off, and like I've seen a few yawns as well. I'm gonna have another sip of water. And it's time to dive into the second part, the third part, and it's like probably the most exciting part for a lot of people. So zero downtime refactoring. I hear a lot of people mention that they're going to have to like take their website down or their application down for like some refactoring. They're going to have to like go into maintenance mode for a few hours. And I think to myself, well, what does your boss think about this? Like, you're like, oh, I'm gonna refactor some code. Like, I'm actually going to take time to not build extra bits for your product. And whilst I'm doing that, I'm also going to take your product offline and costing you a lot more money. That's not a great thing, right? And you don't really see that happen with like an Amazon, for example. Like, I've never seen Amazon go in like maintenance mode or Facebook or whatever. So a lot of these things like are circumstantial as well. If your service that you're working on is not very critical, if you're the only user, well, then you might just do it. Because to achieve this, you'll see that you have to think a little bit different. You might have to add a little bit more work in it. And it depends on your priorities as well. So a big way to achieve this is multi-step changes. And multi-step changes, we covered it a little bit already with type aliasing. Don't know how clear this is. But with type aliasing, we kind of had an example of that already. So what we do it with multi-step changes is we have a stage 1 where we add a new API, and we deploy that. In stage 2, we do some data changes, or we do some code repairs, and that could be like 5 minutes, but that could also take a year. So these two APIs might live next to each other for like a long time or very short. And then in stage 3, we're actually going to just remove that old API from our code base, and then we only have the new one. Again, an example. We're going to use a credential here. Credentials store sensitive information, so we don't want to store the plain text value. We just want to store the encrypted value. So what we have here is a method that does encryption. So encrypt value takes a value and a key. We're going to use AES to encrypt that value. If that error, just return an error, but then store that encrypted value to yourself, and that's fine. We also have a value method which gives us back the plain text value. So we're going to take that encrypted value, we're going to take that encryption key, and we're going to decrypt that value, and we're going to return that. So a little example here is we're just going to create a new credential. We're going to say, oh, my super secret value, encrypt that. Then we're going to get that out again, decrypt it, and we're going to print it. And that looks like this. But we found that AES, for some reason, doesn't really suit what we want to do. So we're like, oh, maybe we should switch from AES to secret box, for example. The issue here is that we have like thousands and thousands of credentials already stored in the database that are encrypted with AES. So how are we going to like do that without actually having to stop everything and re-encrypt everything and then start everything again? So what we can do is we can say we're going to, on our encryption part, we're just going to encrypt everything with a secret box. So what that means is that everything new or everything that gets an update will be encrypted with secret box. So there's going to be a bunch of new values or a bunch of updated values or credentials rather in our database that use secret box for encryption. The interesting part, however, is the plain text or the value function. What's happening here is that we're going to say we're going to try and decrypt this with secret box, and if this works, great. We're just going to return that value, and there's no error, right? However, if there is an error, we're going to say just log it out, and then try and decrypt it with AES. That way, you can also fall back, and that way, if the value was encrypted with AES, it's going to try and decrypt it with secret box. It's going to fail, obviously, but then you can also say I'm going to try and decrypt that with AES now, and then it's going to return that. So this is stage one from that graph I showed you earlier. This is stage one, you deploy that. Stage two, you say, I'm going to create a job that just gets all the credentials out of the database. You just loop over them, and then you're going to get the plain text value out of that. So again, if that was an AES value, you're going to decrypt that with AES, so that fallback is going to be triggered. If that is secret box value, it's just going to give you the plain text from the secret box. And then you're just going to encrypt that again. And again, if that was a secret box one before, you did like a null operation, like you wasted some CPU, but whatever. But if it's AES, you're now going from the old value to actually the new value. And then you just store everything again. And this can like, if you only have like 10 credentials, this is running like super quick. If you have like millions, this might take a while. You don't really care. You just monitor the job to like finish. This is stage two. You just let this, you deploy this and you run this. Then it's time to go to, like this job has finished, it's time to go to stage 3, and what you do is you just remove that fallback, and you just return this. And that's basically multi-step deploys. It looks pretty simple, it is actually pretty simple, but you just need to put some thought in that. You need to like put yourself in that mindset to actually think about how you're going to do that. Yeah, and that's multi-step changes. Again, the example here was pretty simple. It gets a lot more complex, but there's always a way that you can do that. And there's also could also be that you need more than 3 steps as well. Depends on your scenario. So the next part is feature flagging. Feature flagging is actually pretty cool. We use them a lot. And so what feature flags basically are is you say I have my traffic to my application, and I'm gonna, this group of users or this group of people, percentage, type, team, whatever, is going to go to this code base now, or this part of the code base. The rest of the people are just going to go to the old code base. That's pretty interesting, and you can do a lot of stuff with that. So why would you use that? First of all, like early access. I recently saw that GitHub deployed like a new dashboard, and they're like, "You want to opt in?" And I'm like, "Yeah, sure." And that's like a cool thing. Like now you can actually ask your users, "Do you want to start trying this thing?" You might see some issues. We can't promise this is like great, but it's like early access. So for stuff like that, incremental rollouts to test hypothesis. Remember that concatenation function we did? Like, the benchmark is great, but production data is always different, so you want to start actually testing these things on production. And you can say, like, I'm going to start and roll this out to 1% of the users. Then 5%, we see that's still fine. Then we go to 10%, and so on, until we go to 100%. And if all of a sudden we see an issue, we can just use that as a kill switch as well, and actually go back to the old version as well. Or calendar events. There's Mother's Day, there's product launches. Like you want to get that code that you have, you want to put that on production as soon as possible. You don't want to have that linger around until the day of the event, because we all know that if you wait until that day, something's going to be wrong with your deployment deployment pipeline, and you're not going to be able to deploy, and no one's going to be happy. So simple example here, 2 examples. This is the simple one. So the feature percentage is like 10. Then we have like some functions as well. We calculate if we actually should use this new feature, but we're just going over it, and we say if you need to use this new feature, well, use feature B. If you don't, use feature A. That returns this. Pretty straightforward, but your application is probably going to be a little bit more complex. It's going to probably look a little bit more like this. Just so you know, that package, it's a dummy package, doesn't exist. There are some feature flagging packages in Go, even services in Go, which give you like a nice UI on top of it. I linked them at the end of the slides as well. Definitely look into that. But what we're going to do here is we're going to say, from our requests, we're just going to get the user out. So we're going to get the user data out. And then we're going to check, can this user actually use this feature flag? So we're going to do like a check that has this user access to this feature flag. If it doesn't, just skip it. If it does have access to this, actually update the background and make it red now. Again, a simple example, but I hope it drives the point. So what we do here now is just, instead of like doing that percentage, we actually do it based on user roles. So that's pretty powerful as well. What's often overlooked, though, is metrics. Like I said before, like with the unit test, we had that validation. We immediately saw that the new function ran like 50 times quicker than the old function. Simple example here as well is why you should always have metrics is we have 4 services here, and we did an improvement, and we want to kind of test that, right? So we say we're going to deploy canary version of that, and immediately, so the red lines are deploy marks. So immediately after deploy, we see that the response time for that specific replica in our cluster just drastically goes down. And then for a while, we just monitor that, and we're like, oh, we're going to validate it. We're going to check some errors, if there's errors coming in or not. But we don't see anything. So our hypothesis actually is validated. This service is a lot quicker now. So what we do now is, later in time, we just say we're going to roll this out to everything. And again, we do deploy, and we see everything immediately drop. And that's why I need metrics. I think my laptop froze again. Oh, God. Oh, there we go. Sweet. Wait. All right. So experimental refactoring. We've seen a lot of concepts now. We saw how we can do benchmarks. We saw how we can implement feature flags. We also saw how we can use metrics to validate our hypothesis. But now we kind of want to combine all those things, and we want to put that in production and actually test all our stuff in production with production data. Because again, I said earlier, your benchmarks are just a small set of data that you control. It's not really real usage. So you want to test that in production. So how are we going to do that? Just to set the scene, this is the example. So we're going to have a server, and we're going to use that concatenation example that we wrote before. A server that has an endpoint concat string, has a listener, pretty straightforward. Then also has this handler, right? So the first version, we're going to just output this. So we're going to concat the string 100 times, and we're going to output that, and we're going to write that to the response. Now, this is the interesting part. Now we're going to add some like scientific experimentation. I say scientific because the first time I saw this being implemented, and what this is actually like based on as well, is a gem called Scientist from GitHub. They introduced this a few years ago. But the concept here is that you kind of want to have a control group, which is our base function that we start with, and you also want to have a candidate. But in the end, the user, the consumer of your application should never really see that candidate until you say, yeah, they can now. Until you actually say, this is the way forward. So they should always see the behavior of that control group, because that is the control after all. So this is it after we add some experimentation to it. I'm going to go over each part individually. So the first part is we create a new experiment. We're going to run that with a percentage of 20%. So for 20% of the times that people hit this website, it's going to run. There's some other options where you can actually use feature flags as well. It's in the documentation. We're going to run this concurrently as well. So instead of saying we're going to run one test, wait for that, then run another one, we're just going to run all of them at the same time. Watch out with that if you actually this whole package as well, or this whole type of testing, if you do a lot of data changes, this might not be the way forward, because you don't want to change your data in 2 different points. And then we're also going to use a publisher. So I said earlier, I showed you graphs as well. You want to be able to validate that theory. You want to be able to validate that what you're doing is actually correct. So we're going to use a publisher. I'll show you publisher in a bit. The next step is we're going to write that control function. So we're going to add a control function to it. And we're going to just use that concatenation function that we wrote before. The next step is writing that candidate that we're going to run. We're going to call it buffer here. And we're just going to use that buffer function that we wrote before as well. And then this interesting part is basically running that experiment. So what's happening here is if you are within that 20%, it's going to run both tests. So it's always going to run the control. And if you're within that 20%, you're also going to run that candidate. But like I said before, you only want the return value to be that control. So the return values here are actually what are being returned in that control function. And then you write it to the user and stuff like that, which is similar like before. So I mentioned the publisher, so we want to publish that somewhere as well. In this case, we're using the default publisher pack. The publisher that's implemented in there is a log publisher, just see it on command line. But you can write your own. I have an example later on of a statsd one. So yeah, we inject that, and that's it. And then you get this kind of output. So yeah, you hit your website, and for every 20%, again, this gets outputted. You probably don't see it because it's too small, but we see this happening now. Success is false. So we kind of scratch our head and are like, what's going on? Then we realize we actually didn't add a compare function, so we have no idea how to compare our values, so we still need to add that as well. So you add a compare function now, and then you can actually start saying, oh, my test is actually, is the output that the user would see from the control, is that actually the same as what they would see if they get the value from the candidate out. So we implement that, and we immediately see success is true. Great. But what if we deliberately change that function now, and we implement a bug, like it's not the same value anymore? So we update it from value to hello now, so it's always going to use hello as value now. And if you look at that, obviously success is false in that case. For control, so this is the buffer function, so this is the candidate. But for the control, it's obviously true because, well, if your control isn't success, then you have an issue. So yeah, that's that. So success is false here, but the interesting part is that the user will still just see that control function. They only see that value that comes from your control. So they're not influenced by your test at all. So if you think about feature flags, if something is wrong there, they would actually see the wrong value here. But with this, they do not see that. And then, as I mentioned before as well, you can actually add multiple publishers. You can write your own publisher. So what I did for this example is I wrote a statsd publisher. You can use Prometheus or whatever you use. But you can then start graphing this. And what we see here is that the control, so the control is a blue line, and the candidate is a purple line. And we immediately see, so these are timing events, and we immediately see that the response time for that control is a lot slower, obviously, than that buffer. And that kind of that validates our theory that we saw in the benchmarks as well. This is maybe not the greatest example now that I think of it, but like sometimes this could be the reverse, that your production data is like not what you saw in the benchmarks. And that's why this is very useful, because you can actually now test this with proper production data. And that was it. Thank you.